All right, here's example 1.83 from PreCalculus OpenStax. We're given a function and asked to find the inverse of a function. So the way I do this is with a 4-step process. I don't know, you can count them if you want. My first step is I change f of x into a y, which is exactly what your book does, by the way. And then my second step, which is a little bit different than what your book does, is at this point I change all the y's into x's and the x's into y's. The reason why is I think that's more intuitively pleasing. What's going on here is this equation represents the function, but I want an equation that represents the inverse function because I eventually want to figure out the inverse function. This equation represents the inverse function. It's just not written in function notation because in function notation we have to solve for the output, and the output is the letter y right here. So my next step becomes solve this thing for y. And solving this thing for y, you have a few options. I mean, I guess the first thing that you want to notice is that this y is down in the denominator, so that's going to make things a little bit challenging. One option is, oh, I got fractions. I don't like fractions. Let's multiply both sides of the equation by y minus 3. You could do that right now, multiply both sides by y minus 3. Just be careful. Make sure that y minus 3 hits every term. Here's a term, here's a term, here's a term. So you'd have to make sure your y minus 3 gets multiplied by this 4 as well. What most people do, and frankly I think this is the easiest way to do it, is first subtract 4 from both sides of the equation. And now multiply both sides by y minus 3. So I got x minus 4 times y minus 3 equals 2. The reason I did that is now, even though this y is kind of hidden with all the parentheses and such, the good news is that this y right here, at least it's in the denominator. I'm trying to solve for it, I at least want it up in the top, not down in the bottom, to be very imprecise. At this stage you have a couple of options. You could FOIL this thing out, but actually you won't want to FOIL this thing out. You could, it'll work perfectly fine. You could FOIL this out here, collect all the terms that have a y in them on one side of the equation. You'd end up having to factor again later. So to be more straightforward, wait, I just want to solve for y and there's only one of them written right here, just isolate that y. Divide both sides of the equation by by x minus 4. That leaves me with y minus 3 equals 2 over x minus 4. And then add 3 to both sides of the equation. 2 divided by x minus 4 plus 3. Had I been in the situation where there was a y over here and a y over here, I would have had to FOIL this back out and then collect all the terms that have y's in them. So I'm going to show that as optional. For this specific problem, it'd be a lot more work, but I feel like it's a good skill, optional, to have for a different problem where the algebra doesn't work out quite as nicely. But actually, before I go moving on, let me finish up this problem. I should put it in function notation, so f inverse of x is 2 divided by x minus 4 plus 3, something like that. Optional is from this step right here, I could have also FOILed the left-hand side out. That would give me xy minus 3x minus 4y plus 12 equals 2. And then, let's see, I want to solve for y. Oh, there's a y here and a y here. Okay, collect all the terms that have a y in them on one side of the equation and get all the terms that don't have a y in them on the other side of the equation. So all I did here is I added 3x to both sides. That appeared right here. And then I subtracted 12 from both sides, but 2 minus 12 is negative 10. That gets me to this step. I want to solve for y. There's a y here and a y here, but I can factor. If I factor out a y from each of these terms, gets me to this stage. And now I can divide by x minus 4 to get that y is equal to 3x minus 10 divided by x minus 4. Uh-oh, this looks a lot different than this. Should I be worried? No, you should not be. And the reason you shouldn't be worried is they're equivalent, just written in different forms. And the way I can prove this to you, and again, you don't need to be able to do all this for this problem, but it's good to have these algebraic skills in case you need them later on. Note that if I wanted to mash all these together so that it was all over a common denominator of x minus 4, so it looks more like this, I would think about this as 3 divided by 1, and then multiply the top and the bottom by x minus 4. So then really what I have over here is 2 divided by x minus 4 plus 3x minus 12 divided by x minus 4. Note I took this 3 and distributed it through. But wait, I got a common denominator, and I learned that when you have a common denominator, you can just, with fractions, you can just write that once on the bottom and add up the stuff on the top. So up top I'd have 2 plus 3x minus 12, and maybe you can kind of start to see the finish line here if you combine like terms. 2 minus 12 is negative 10. And so what you get is that this thing right here is equal to this exact same answer that I got over here. No reason you had to do anything beyond the red stuff, but I feel like these algebraic skills are good to have, so I talk you through them sometimes.